5.5 is on the conditions for rhombuses, rectangles, and squares. And when I look at what we have to do, we have 4 different theorems that we are going to write. And we have 2 examples. So let me get over to this screen right here and make sure that you guys can see it on the screen, which you can. And I'm going to recommend to the substitute teacher to press the enter button while students write down the notes, and then when they are done writing down the notes, that you could press enter again to get back to the video. Go ahead and press enter now. Coming back to you for 5.5, I'm going to explain these 4 different things that you wrote down, and then we will do a couple of examples. So here we go. First and foremost, if a parallelogram has diagonals that are perpendicular, then it must be a rhombus. If I think about that, and I have a diagonal here, and I go over there, and I have another diagonal there, and these 2 diagonals were a perfect right angle. They have to be a perfect right angle. Then it must be a rhombus. Anything else, it would just be a parallelogram. Possible to be a rectangle when I think about that, but it could not be a rhombus. If diagonals are perpendicular, it's a rhombus. It could, if the diagonals are perpendicular, could be a square, but we don't know if it has 4 congruent sides. Remember, a square has to have 4 congruent sides, and a rhombus only has to have 4 congruent angles and 4 congruent sides, whereas a rhombus only has to have 4 congruent sides. This being 90 degrees would make sure that we had 4 congruent sides. The second property is that if one diagonal that bisects a pair of opposite angles, then it's a rhombus. Let me just make a one diagonal parallelogram here. If a parallelogram, there's one diagonal. And so, if it has one diagonal and it bisects, this angle is cut into 2 equal pieces, and that one's cut into 2 equal pieces. If the one diagonal bisects each pair of opposite angles, it must be a rhombus as well. Because the rhombuses are the only ones where you have this angle-side angle that makes this triangle congruent to that triangle. And so, since it's a parallelogram and the opposite sides are the same, and we have these isosceles triangles, what you can do is you can go, oh, it's got to be this. And that makes me want to remind you, that's the whole reason we learn stuff from chapter 3 first. We learned in chapter 3 5 different ways to prove that triangles were congruent to each other. We learned side, side, side. We learned side, angle, 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 side, and this last one called HL. We learned that because a lot of the proofs, a lot of the theorems in the quadrilateral and parallelograms units uses these triangles to prove that other things or other facts about things like a rhombus, a rectangle, and a square. It builds off of each other. It's kind of neat. It's really logical. I love it. It's awesome. If a parallelogram has diagonals that are congruent, then it has to be a rectangle. So think about that. If this diagonal had to be the same distance as this diagonal, because right now when you look at this picture, these two, you can obviously tell that this diagonal is a lot longer than this one. But imagine stretching this one until, I don't even know if I can select this anymore. I might be able to. Imagine stretching this one out until they were exactly the same length. I'm going to try taking that. That didn't work very well. But if I had to and make them the same length, Look at the kind of shape. What would that be if they were the same shape? It has to be a rectangle. That distance becomes the same distance as this, and it's a parallelogram, and the opposite sides are the same. It's going to make a rectangle. It's the only one. The rectangle is the only one that has diagonals that are congruent to each other of the ones we learned in the previous section. And lastly, if a parallelogram is both a rectangle and a rhombus, then it must be a square. Since a rectangle has 4 right angles, and a rhombus has 4 congruent sides, if it is both a rectangle and a rhombus, then that is a square is the only one that has 4 right angles and 4 congruent sides. It has both properties. That should make sense to you. Yay! Okay, with that being said, we're moving on to number 2. Can you conclude that the parallelogram is a rhombus, a rectangle, or a square? And explain. So this is a parallelogram. This is given. Oops, switch back over to the pen, please. This is given. It's a parallelogram, given. Is it a rhombus, a rectangle, or a square? If it's a rectangle, then this diagonal would be the same as this diagonal, which, because that's a 1 and that's a 1, these are the same, and this is a 2 and this is a 2. These are the same, but they're not necessarily the same as each other, so it can't be a rectangle. I don't see any way that I can prove that this is a right angle or this is a right angle or that there's 4 congruent sides. So I can't say that it's a square. And the square, these 4 would be the same as well, and there'd be a right angle in the middle. And it would be a rhombus if I knew that this side was the same as this side, is the same as this side, and the same as this side. But I'm looking at this angle here and this angle here, which I know are the same. So I know this is congruent to that. And then these vertical angles here are the same, but a 1, a 2, and a 2, and versus a 1, a 1. These aren't necessarily the same as those. So I can't say that it's a rhombus either, because I do not know if this side here is the same as this side there. There's no further information that I have that can prove whether it has 4 congruent sides. And we don't know if there's 4 congruent angles, and we know that the diagonals aren't the same as each other. So there is not enough information here to say that it's one of these 3 things. I'm going to say, can you conclude? I'm going to say no. There's not enough information so far. These diagonals bisect each other. Which is a property of all parallelograms. If I were to go to 5.2 notes, you would see the diagonals bisect each other. It's a parallelogram. Yes, I already know it's a parallelogram. That was given, but we don't have any information that would give us or lead us to believe that it's a rhombus, a rectangle, or a square. Plus, it doesn't have any of that. I hope that makes sense to you. Number 16. For what value of x is the figure the given special parallelogram? Like this needs to be a rhombus. So what does x have to be for this to be a rhombus? That's the question. Let me let you look at that for a second. If it's a rhombus, I know something's true about it. I know something about this diagonal, this diagonal. If it's a rhombus, this angle here has to be, if you said perpendicular, great. I was hoping you were going to say 90 degrees. They're perpendicular and 90 degrees, same thing. And now, if that's 90 degrees, then that means these two, if it's going to be a rhombus, they need to add to be 90 degrees as well. Because this plus that should add to 180. That means these two are complementary. That will be the shortest way to do it. I'm going to put 3x plus 6 plus the 8x plus 7 should have a total of 90 degrees because with that 90 would make 180. Let's put that together. 11x plus 13. I'll subtract the 13. Oh, very nice. For what value of x? We found it. What I like to do after that is I like to plug it back in. What if I plugged 7 in there and 7 in there? Let's see if it makes sense. On. 3 times 7 plus 6 is 27 degrees. Let's put a 27 right there. 8 times 7 plus 7 is 63 degrees. Let's see if that makes sense. Does 27 plus 63, does that equal 90? 63 plus 27 is 90 degrees. It works. We've answered the question. But I also love to show you how you plug it back in to figure out what the angle is. Super important, especially in honors geometry, because they almost always will ask you on a test. Don't just do what they do in the textbook authors. These textbook authors don't know you as well as I know you. I know you so well that I go, you know what? These kids are so smart. They can do this. They can plug that back in and figure it out. But make sure you read the question. Become test smart, test savvy. You guys got it in you. We're going to end your notes right there. We'll see you in the next video.